Hello students, in the previous class we have started with the introductory part of the chapter chemical kinetics, and we have learned the various classification of the reactions based on the rates, that is rate of reaction, and we have learned how to write the rate of reaction. Today we will learn about the various types of rate of reaction and the details of the rates of reaction and the factors that affect the rate of reaction. Okay. So the various types of rate of reactions are the average rate, instantaneous rate and initial rate. So first let's discuss about the average rate. See, in the previous class I have discussed that the rate of reaction is given by the change in concentration of reactants or products per unit time. So when we write the rate of reaction in that way, there's a difficulty arises. Now why is that? This is because according to the law of mass action, the rate of reaction depends upon the molar concentration of the reactants, which keep on decreasing with the passage of time. And if we speak about the products, the molar concentration of the products, it increases with the passage of time. So we can say that the rate of reaction does not remain constant, means throughout the rate of reaction is not constant. So the rate of reaction can be explained as the average rate of reaction during the time interval which we have chosen. Okay, so the expression for the rate of reaction in the means according to the law of mass action, we can express that as the average rate of reaction. So instead of writing the rate of reaction, we will use the average rate of reaction, and we will express that as the change in concentration of the reactants or products per unit time. So the average rate of reaction can be expressed as, that is the R average, this is average rate of reaction, is equal to minus delta concentration of the reactant by delta T, that is change in concentration of the reactant. Now with respect to time, the concentration of the reactant decreases, so the negative sign is over there. And in case of products, the concentration, molar concentration of the product, it increases, so there is a positive sign. So in general we can say that R average is equal to del X by del T. Now this X means that is how much concentration of the reactant or product, means how much change is there in the concentration of reactant or the product. Okay, so this is about the average rate of reaction. Then what is this instantaneous rate? The instantaneous rate of reaction, that is the rate of reaction at any instant of time. Okay, it is the rate of change of concentration of any of the reactants or products at a particular instant of time. Okay, here average means it is the overall thing throughout what is the change, but in case of the instantaneous rate, we will find out the rate of reaction at a particular instant of time. Okay, so in case of the instantaneous rate, we can write that instantaneous rate, that is R instantaneous, it is equal to dx dt. Okay, again here we have chosen this one because this shows the small interval of time. Okay, whatever interval we are taking, that small interval is taken as small d. Okay, dt is the small interval of time, and this is the small change in concentration of the reactant or product. So in this way we can show the various types of reaction according to their rate. So the symbol delta is used for the large change. Here this is used for the large change, that is the average rate, and in case of this instantaneous rate we use small d due to indication, means due to the indication of the small change. We want to indicate the small change in the concentration of the reactant or product, or here it is the small change in the time. Okay, now if we want to measure the rate of reaction, then we can study the concentration of one of the reactants or any one of the products at different intervals of time. Okay, if the concentration of one of the reactants is studied at different intervals of time and then those values are plotted against the corresponding times, then we will get a graph. Okay, so if we plot that graph, let me show you first. Look at this graph. Here it shows that this is the concentration of the reactant, this axis, and this is the time in minutes. Now this point, this is the initial concentration of the reactant, that is 0.05 moles per liter. Okay, now after some time, suppose we want to get the rate of reaction at time 10 minutes. So at any time, if we want to know the rate of reaction, then for any graph or for any curve, we need to draw a tangent at that instant. Okay, so here we want to find the rate of reaction at this instant, that is time 10 minutes. So for this time, we will draw one tangent from this point. Clear? So if we extrapolate that tangent, then it is cutting here at 0.04 moles per liter and here at 20 minutes. Now for the calculation of rate of reaction, again the simple calculation, that is the change in concentration by change in time. So here see, the initial concentration was 0.05 and the final concentration was 0.04. So we will get the change in concentration. Here it is, suppose we name it as A. For this instant, suppose it is A. And for here it is B. So here the change in concentration will be OA by OB, because it is the change in time and it is the change in concentration. So we will get the slope of the tangent in this way. Clear? So if we write that the rate of reaction, the instantaneous rate is given by minus dr dt, that is the change in concentration of the reactant per unit time or in the interval of time. So it is the slope. So the slope is the negative slope for the instantaneous rate. Clear? Now for the average one, here again we will see the change in concentration of the reactant. So for the average one, we will take this curve, and for there again it will be concentration R dt. So this will turn to be, for the average rate, let me show you. See here, if we take this one, this point, okay, let me show you, wait. For average rate, we will take a large gap. So if the change in concentration is from here to here, this gap, okay, so let's take this one as x1, that is the initial concentration of this one, and if it is x2, then change in concentration here will be x2 minus x1, because from here to here it is the change in concentration. Now for delta t, see here, for x1 the time is t1 and for x2 the time is t2. So here delta t will be t2 minus t1. Clear? So in this way we will calculate the average rate of reaction and the instantaneous rate of reaction. Clear? Whatever the values are from the graphs, we will put the values and then find the exact value of the rate of reaction. Clear? So for instantaneous rate also, let me write. Here it is the negative slope. The slope will be this value by this value, that is the change in concentration by change in time. So it will turn to be, if we name it as O, so it will be OA by OB with the sign, of course. Clear? So in this way we will find the instantaneous rate and average rate. Now if we want to calculate the rates from the plot of concentration of a product versus time, here it was the concentration of reactant. If we want to plot the graph from the concentration of the product versus time, then we will plot it in this way. Look at this. This is the plot of the concentration of a product versus time. Now we know that for the product, initially its concentration is 0, right? and after some time its concentration gradually increases. Okay, so if we want to get the instantaneous rate, suppose we want to get the rate at this time. Okay, so here we will again draw one tangent, and with respect to this tangent we will extrapolate this one and get the slope. So for the rate of reaction, here the slope will be again change in concentration, that means this one OA by OB by change in time. So the instantaneous rate will be, that is the slope, positive slope, here it one, that is simply OA by OB. Now if we want to get the average rate, in that case here again we have taken a larger span. Suppose this one is the initial concentration and this is the final one. For this concentration the corresponding time is T1 and for this one it is T2. So the average rate will be which one? Again change in concentration by change in time. So it will turn to be this one. Clear? So here in this way we will plot the graphs of the concentration of reactant versus time and concentration of product versus time, and we will get the separate plots for the separate parameters. That is, for reactant the slope will be negative and graph will be in this way, and for the product the slope will be positive and here the graph will be in this way. Clear? So this is how we will measure the rates of reaction according to the instantaneous rate and the average rate. Clear? Now what is the initial rate? We have discussed the average rate and instantaneous rate. So what is initial rate? Initial rate of a reaction is simply the instantaneous rate at the start of the reaction. Okay, when the rate of reaction means we will calculate the rate of reaction at time t equal to 0, that is at the initial moment. Clear? So the initial rate is equal to the negative slope of the curve of reactant concentration versus time. Let me show you. So here you can see that with respect to the concentration of reactant at time t equal to 0, whatever the reaction concentration was there, the rate of reaction at that instant, that is at time t equal to 0, is the initial rate. Now about this initial rate we will discuss it later in detail. Okay, so for now just keep it in mind what is the average rate and instantaneous rate. Now we will learn what are the factors that affect the rate of reaction. There are various factors that affect the reaction rate, and among them the first factor is the nature of the reactants. Look at these two reactions. Here the reactants are quite similar but not the same, but depending upon the nature of the reactants the overall rate of the reaction will vary. Now see, both these reactions they are quite similar, at least they appear to be similar, right? So here what happens, their reaction rates are different. The first one, that is this one, is quite fast and this one is quite slow. So why is this so? This is because different amounts of energies are required to break the different bonds. Okay, and some different energies are released for the formation of different bonds. So here the again the same thing, that is the bond breaking and bond making parameters are responsible for the various rates of reaction. So for the formation of the bonds energy is released, and depending on the nature of the reactant that energy is calculated, or that energy depends. And again for breaking the bond, the energy required, that one is also different, and that depends on the nature of the reactant. Whatever reactant we have taken, it depends on that. So in this way the nature of the reactant is an important factor to determine the rate of reaction. Clear? The next point is, or next factor is the concentration of the reactants. See, for a reaction to proceed, we need a greater concentration of the reactants. So, greater the concentration of the reactants, faster is the rate. And conversely, if the concentration of the reactant decreases, then the rate of reaction will also decrease. So, concentration of reactant is an important factor that affects the rate of reaction. Another condition is the temperature. In general, we have the idea that with increase in temperature, the molecular kinetics increases. So, the reaction becomes faster. So, the rate of reaction increases with the increase in temperature. In most of the cases, the rate of reaction becomes nearly double for 10-degree rise of the temperature. In the same case, the reactions do not take place at room temperature but take place at higher temperatures. Okay, so this temperature is another important factor that affects the rate of reaction. Another thing that is the catalyst. We know that catalyst has an important role to increase or decrease the rate of reaction. Some catalysts, actually most of the catalysts, they generally increase the speed of the reaction without itself being directly involved in the reaction. So those catalysts which increase the rate of reaction, they are called the positive catalysts, and some catalysts are there which are required to control the rate of reaction in order to get the desired product. And those catalysts which retard the rate of reaction or decrease the speed of reaction, they are called the negative catalysts. Now, in case of the reversible reactions, a catalyst helps to attain the equilibrium quickly. Okay, so whenever there is a reversible reaction, when we use the catalyst, it helps to attain the equilibrium quickly without disturbing the state of the equilibrium. Clear? So this is another important factor. Next thing is the surface area of the reactants. See, in some cases, generally for the reactions that involve the solid reactants or the catalysts, in that cases the particle size is small, and as the size of the particle is small, the surface area will increase. Means smaller the particle size, greater will be the surface area, and hence the reaction rate will be faster. So surface area of the reactants also help to control the rate of reaction or to enhance the rate of reaction. The last thing that is the important factor which affect the rate of reaction is the presence of light. For the photochemical reactions, that means those reactions which do not take place in the dark but they take place only in presence of light, in that case light is an important factor to increase the rate of reaction. So those reactions, means for the photochemical reactions, the rate of reaction will increase only in presence of light. It decreases in absence of light or in absence of in presence of dim light. Okay, so these are the factors which are responsible for the rate of reaction. This is all about today's class, and in the next class we will learn about the rate law and the various factors that are connected to this rate of reaction. Okay, like order, molecularity, rate constant, like this. So in the next class we will learn about all those, and this is all about today.